Hello again. In software, loops are very common, and ARD supports test design for loops very well. It has some great features to help us. So I'll use this video to explain how we model loops and generate tests for loops. But it's also a means of showing you how test design with ARD is an iterative or incremental process as well. We build up our set of tests, not just press a button and out all the tests pop. So firstly, I'll talk about loops in software and just explain what they are, and mention some other types of loops, or where loops are used in combination, if you like. Now, there's a kind of a caveat in that not all loops actually need testing, and I'll explain what I mean by that in the session. Then we'll go into a demo of the tool, and I'll talk about testing loops and how we use the features of ARD to help us to generate selections of tests which we might pick and choose from in order to give us a good set of covering tests. So I want to talk a little bit about iterative test design using loops as a vehicle for making some explanations of how this works. After the demo, then I'll just summarize what we've discovered and seen in the demo. A loop is a decision outcome that routes to a previously executed part of a model. If you like, an outcome of a decision feeds back to some earlier part of the model or software which has previously been run. So this is how we design software to iterate or repeat itself, to do the same process on all records in a database, or to scan text for a string when we're searching, to count occurrences of events, objects, messages, the length of messages, that kind of thing. We also use loops to support repeated user actions, like adding items to a purchase order, for example. Now, in a user interaction, loops might be traversed only once or twice or 3 times, and a very few numbers of times. But in programs that process millions of records, the loops themselves are traversed millions of times. Now, where each record transaction is independent in batch processing of data, if you like, we don't necessarily pay much attention to the looping activity. We model the data and look at the data as the mechanism for covering the software itself. But overall, loops need a slightly different treatment when we test, and I'll explain how that works. So firstly, a loop can be executed 0, 1, or any number of times. And in order to allow for a 0 iteration, there might be some kind of check at the start, some condition that must be met to say whether you even enter the loop in the first place. Once you're inside the loop, a check condition again is made at the end of the block of code or activities that say, have we completed this task? Should we go back to the start of the loop and repeat it again? If we have finished, the loop ends. So we have usually some kind of entry criteria and some kind of exit criteria for our loops. We don't need an entry criteria if we are guaranteed to exercise a loop at least once. Now, the other thing to say is what I've shown on the right is a very simple model, just with 3 elements. But obviously loops tend to be part of much bigger models. So if there's a kind of an entry condition for the loop, before you get into the processing of some data inside the loop, there's a check. And the check might be something like, are there more records to process in this file? Has a new message been received? Has the user selected an order to update? Does the user want to add another record, another item on their purchase order? And so on. Now, the other form of loops is where the check is done at the end of the loop. In this case, the loop is entered, some processing happens, do more stuff in my little example here, and the loop is repeated until a condition is met whereby the process has come to an end. And typical examples here is where the user adds items to a shopping basket, but ultimately needs to check out, and it's the checkout option that closes the repeated loop of adding items to the purchase order. It might be that an error occurs. So again, sort of where a process happens, an error occurs, that might be the trigger to close the loop and to move on to the next piece of functionality in the system. It could be is there another record or message to process? Again, the check for more data to process might come at the end, or as we saw in the previous slide, it might come at the beginning of the loop. So you can see that loops are not so complicated, but essentially they cause functionality to be repeatedly executed by some means. Now, the other way of looking at loops is how they're used, and occasionally we might have one loop followed by another. They're sequential. So we have, if you like, a whole series of paths exercised within the loop, and then another loop to follow generates another set of combinations of paths as well. So I hope you're beginning to realize that actually loops generate many more path conditions or possibilities that we might have to pay attention to. So on the left we have one loop followed by another, but another common occurrence is where one loop is nested inside another. So where perhaps you're looking at records in a database searching for text, there's a loop to process every record in turn, but there might be a loop to scan the content of a data field inside that record. So we have this loops inside loops inside loops phenomenon, which sometimes occurs and obviously is a tricky thing to test sometimes. Now I should say that actually not all loops need testing, and let me explain why I say that. So if we have a batch program that is processing millions of records, we would spend most time focusing on the processing of each individual records, because very often it's true to say that each transaction, each record that is processed, is independent of the one before and the one that follows. So in effect, the loop isn't the point, let's put it that way. It's the processing of each individual record that we must pay much more attention to. The loop itself might be very, very simple and take no effort at all to test. Although the program will process millions of records, what we discover is that only a relatively small number of test cases might be required to test it. And this is a common situation. It's not about the quantity of data, it's about the complexity of processing. So as you would understand from a complex model, and a complex model takes more paths to test, to cover. And it's the size of the model that determines essentially how much testing we have to do. Now, the classic approach to testing loops is to set out a number of iterations to exercise in each test case, if you like. So clearly, for a loop designed to run n times, whatever n is, we might say, okay, we should construct a test to exercise a loop with 0 iterations, if that's possible, with 1 iteration. Maybe we add a sort of a typical number between 1 and n. So if n is 10, we might say, let's put a test case with 5 iterations. Typically, we'd look at the maximum number of iterations, subtract 1 and say that's the last but 1 case. And then we'd look at n, the maximum number of iterations, of course. And then we might try, if it's possible, to impose n plus 1 iterations on the loop. So this is the classical way of testing loops. So let's look more closely at a user interaction modelled with and without loops and see how we build up a range of useful test cases. Okay, so here we are in Agile Designer again, and I'm going to show you a model of a sequence of actions for a user accessing a website to purchase books. So the model I'm going to show you is like a subset of all the functionality that a user would follow, but it focuses on searching and adding books to a shopping cart. So if we look at the model in a bit more detail, I have a search for books, and then the search might result in some items of interest or not. If there's nothing to be seen, this process comes to an end. If there's items found and there's one of interest, I might select it and look more closely at it. Otherwise, again, I might come to the end and that would be the end of the process. If I select it and it's in stock, I might continue, but if it's not in stock, that would be the end of the process. If I add the item to my order, I have a decision to make here, whether I do or I don't. If I don't, that's the end of the process. If I add the item, there's the activity of adding it, and that's the end of the process. So in effect, there are 4 opportunities to bail out of the transaction or to carry it through to the end and add the item to the order. So that's the core functionality that I might want to test. Now let's look at the Path Explorer and just it's a fairly simple process, but I'm going to look at all possible paths and just see what comes up. And there you see 5 paths, and pretty much there are the 4 opportunities to bail out, and then there's the 1 path all the way through to the end to add the item to the order. So five paths gives us everything that we need in terms of testing this little sub-process, if you like. So that's the model of the sub-process of adding items to an order on your e-commerce site. So what I want to show you is that same process in the context of, with some loops to control the user experience, if you like, because when you come to a real site and you search and add items to an order, you ultimately will check out. So the ultimate goal is to check out. But there are some other loops than just going back to the beginning again to add another book to your order. So I want to explore this model in a bit more detail. So I hope you can see, but this section of the model, these 5 elements here, represent the 5 elements in my model here, and add item to an order, this one in blue here, I've left as purple, oh, beg your pardon, I've left as blue over here. So the core of the model is the same. All the opportunities to bail out of the adding an order go to a no action process, and you're taken to the start. So let's look a bit more closely at the start of the model. So we have the first challenge is, are there any items in the basket already? And there's a true and a false outcome, and this is a check just to help us to control the flow through the model, because if there is nothing in the current basket, then we can't check out. And if there are no items in the basket to delete, we should not be able to delete an item. So if you like, we check the items in the basket, I make a menu choice, delete an item, to check out and end the process, or to proceed and search for another book. So this menu choices gives us those 3 options. We search for books, and then we're into the 4 opportunities to bail out of the process, or if we proceed to the end, we add an item to the order. In all cases, there's a feedback loop. Just move that back. There's a feedback loop to items in the basket, that check. Now, just to give you a sense of how the invalid paths are constrained, let's just look at constraints in the model. And in here you can see there are 2 constraints. The first one is if there are no items in the basket, then you can't make the menu choice delete an item. So you can't go here. The second constraint is, again, if there's no items in the basket, then you can't check out. And that kind of makes sense. So let's close that. And go to the Path Explorer. So in the Path Explorer, let's look at all possible paths. Let's see at how many paths we can generate just based on the model as it currently stands. And what we get is just the 1. Well, that can't be right. How can we just have the 1 path? Let's go back to the model and just take a look at and see. The path that it chose was from start, items in basket, menu choice, checkout and end. That seems fairly straightforward. That was the only path it generated. Why didn't it go down here to search for books, whatever? Well, because I was searching for paths between start and end, the start point and the end point of the process, and there's only the one start and the one end, when it came down to look at the paths down these, because I hadn't taken the option to process loops, it ignores all paths that are dependent on a loop back to the beginning. So the only valid path that the optimizer can find is the one to go directly to the checkout and end, which is a bit nonsensical, but that's the way it is. So let's go back to the Path Explorer and just let me show you how it really works. So we have this challenge of looking for all possible paths, but there's an option here in the center of this cluster of buttons, which is loop settings. We need to look at this in order to process loops. So there are actually 3 loops in the model, as you can see. And what I'm going to do is I'm going to focus on this one, add items to order, the one towards the bottom of the model, which comes up here and then back to the beginning. So what I'm going to do is say, let's just look at that, process that loop once, execute that feedback loop once, okay? And we'll accept that. And now look for, let's say, full coverage of all possible paths. Oh, we still only have 2. But that kind of makes sense to some degree, in that if you look at what these paths are, the first one is the basically starts, it adds an item to the order, so it comes down the straightforward path to the bottom and then goes to the checkout. So the full path is to come down, add one item, come back to the feedback loop, then go straight to the checkout. So that's kind of consistent with our requirement to process that loop at least once. So our target of having all possible paths, that's kind of constrained by our need to exercise loops 1 or more times. Okay, so let's look a little bit more closely at how we could have all 3 loops executed. So let's look at 1, 1 and 1 for the 3 loops. So we're forcing the optimizer to generate at least one test case with that loop involved. But at the same time, we're looking at all possible paths that involve those loops. So we'll accept that, and we'll do all possible paths again, see what comes up. So now we see we get 20 paths, which is much more like it. And let's look at these paths and just see what kind of things we're getting here. So here we have it looks like it does a delete an item, then a checkout. That doesn't make a lot of sense because we haven't added any items to the order yet, but whatever. This one looks like it's coming down, doing a search, add item to an order, checkout. Okay, that's a single item checkout. That looks good. We like that. Here's another one, add an item to an order, delete an item, then checkout. Well, that may not make as much sense. How about this one? This is a go direct to checkout, don't add any items. Maybe not much sense there. Add item to an order, do a checkout, no complications, and so on. If you look at the number of nodes here, we'll probably see, I think 24 is the biggest. So here we have search your books, but it doesn't add an item until it's gone through the search once, twice, twice. So then it adds an item, then it deletes an item, then it checks out. So again, that doesn't make a lot of sense. What's happening here? Well, let's go back to the loop options. Let's look at the 3 loops in turn. The first one is the no action loop. So what this is where we do a search and we take no action. We don't commit to adding an item to an order. The second one is add an item to an order and then go back to the beginning again. And then the third one is delete an item. So you could say that if the no action one doesn't have any effect on the basket, adding one item 1 and deleting an item 1 is going to lead us to create some tests, some paths, which basically add an item and delete an item, then check out. Or they would delete an item, then add an item, and then check out. And both of those scenarios don't make a lot of sense. So if you like, to make sense of what we have here, it might be better to say, let's have no bailouts on the searches and no deleting any items, and let's add 5 items to an order. So what we're doing here is we're going to add 5 items to the order in some test cases and check out with no deletions and no bailing out halfway. Let's see what this gives us. Okay, we'll do all possible paths again. Takes a bit longer, and you can see the numbers are getting high. And what we have are 6 paths. Let's look at these paths in turn and see what we've got. So the first path basically does a complete run through, adds an item, then checks out. The second one adds 2 items, checks out. 3 items, checks out. 4 items, 5 items. And the last path simply goes directly to the checkout with no items. So what we have here are 6 paths with 0, 1, 2, 3, 4, 5 items added to the order in each case. And the paths, all possible paths that it's selecting, are relatively simple because it's ignoring the delete loop and it's ignoring the bailing out loops, if you like. So what we have with this setting is we want to have up to 5 iterations of this particular loop, and for each of those iterations it looks at all possible paths, for which actually the path is pretty constant in that it's just a loop all the way around this way. So if we have one loop and we do all paths, life doesn't look too bad, depending on the number of times we go around that loop. But let's try 2 loops now, where we'll have one occurrence of no action, where it goes through the motions of adding an item but bails out. Now if I did all possible paths, I'm going to preempt the conversation and say actually that will take quite a long time to generate. So I'm going to actually look at all edges. Now an all edges coverage isn't a terribly ambitious target, but you can see how long it's taking and how much calculation the tool is doing to reach its optimization. Now I can say that actually what it's trying to do is it's taking the 6 iterations of 1, because you've got 0 up to 5, that's 6 altogether, and the 1 iteration of the other loop, the do nothing loop. And in terms of all paths through each of those sections, what it's doing is it's multiplying those 2 sets of paths, which is an extremely large number, and then it will remove all, if you like, the duplicates in order to achieve all edges coverage. So it's doing an awful lot of work to end up with what I expect to be quite a small number of test cases. Let's see what it comes up with. Five paths after all that work. So I think what you can see is if we look at looping, if we have anything more than a minimal number of permutations of loops here, the combinations of all paths versus all paths, you know, it just explodes. Okay, so what I'm going to suggest is actually we need to be very careful with how we do these loops in combination. Let's pause for a minute and just step back and consider where we are with these loop options and the generation of paths. It's clear that for every model with loops, the optimizer is very sensitive to the loop settings, and if you're using loops in combinations with multiple loops all having multiple values of iterations, you're going to end up with some very complicated calculations and potentially a very large number of paths. What I want to do is to offer my pragmatic guide to achieving a good set of tests with loops. I'm not going to explain in too much detail about why I've made these choices, but they work for me. In every case, your model will be different to what I've demonstrated here, and you have to kind of play with the optimizer in order to get comfortable with the number of tests generated and the meaningfulness, if you like, of those tests. But here's the method, if you like. Firstly, for each loop that you have, go into loop options and set the count for that loop to be an appropriate number that you think you want to cover. So in my add items to order, I would say I want to add 5 items to an order, and that will test that process. For the other loops, set them to 0, or if it's meaningful or only meaningful for those loops to have a count of 1, set it to 1. So for the other loops, 0 or 1. In the optimizer, choose the coverage target that feels appropriate and generates a reasonable number of paths. A coverage target that generates 20,000 paths is not of much use to you. You need to have something between 4, 5, 6 and 10 to 20. So that's the kind of the scale of it. Some that you need to generate a number of paths that you can review in a reasonable time and select those that are meaningful or add value to you. So if you like, the generated set of paths, go through them end to end and pick the ones that you believe add value to you, and the combinations and permutations that are obvious will stand out, and these are the ones that you should save. You do that process for each of the loops. Now the next stage is take all the loops and set them to your desired number of iterations, and you know that would generate a very large number of combinations of permutations. So there is a setting against each loop, which is the fixed insertion box. Check that. And what that will do is it will force the optimizer, if it's going to use that loop at all, it will iterate through that loop the desired number of times. So it won't do 0, 1, 2, 3, 4, 5, it will just do 0 and 5. So that will speed up the process considerably. So do that for each loop. Then in the optimizer, choose the coverage target that feels most appropriate and generates a reasonable number of paths. Again, less than 20, I would say. Of the generated tests, review those and save those that are meaningful and or add value. The combinations and permutations that look most interesting. Certainly there'll be one path which involves the desired count for each loop. So that will be quite a complex test, but that will be the test to end all tests in your plan. When you've done that, review all the tests you've saved and consider whether what you have in front of you is appropriate to give you the desired level of confidence. Okay, so let's see how our method for selecting test cases for loops actually works in practice. So let's go to loop options, and firstly I'm going to look at the no action loop, and for this to be meaningful there has to be at least one item on the order in order to get to the checkout process. Delete items can be left as 0. Set that. We'll look at all possible paths and generate, and I've got 10. So what's interesting about these is you can see that I've got all the combinations of no actions as I go through, and some have add item to order and some don't, and in fact half of them have the add item to order and half of them don't. So let's go to the top and pick the ones that have meaning. So they have to have add item to order and checkout, and one of the no action options. So we'll take the first one, take the third one, the fifth one, the seventh one, and the ninth one, and that's the direct to checkout. So these are the ones that we'll save. So I'll save selected, and these are our first 5 test cases. I'm going to loop options again. So we'll take that out. We'll add 5 items to the order, but there's no action options, and there's no delete an item either. All possible paths. And we just have these 6. So let's look at these. So here we add 1 item checkout, 2 items and checkout, 3 items, 4 items, 5 items and checkout. And this one goes directly to checkout with 0 items. So I think we take all these, but not the last. Save selected. Okay, we've got 1 duplicate, that makes sense, so we'll not worry about that. Okay, so now we need to have 1 deletion, and in order to have 1 deletion and to have an order with more than 0 items, we need to have 2 items. So we're going to add 2 items, 1 deletion, and that should make sense. We're not going to have any no action. Paths. 5 items again. So what we're looking for is adding 2 items but having a delete an item in. So there's no add there, that's no good. There's an add but no deletion. An add and 1 deletion. 2 adds, 1 deletion. We like that one. So we'll take number 5. And that's the direct to go. So actually we're only going to take 1 test from that collection, so we'll save that. So we have 10 test cases so far, and that is covering the situations where we're focusing on 1 loop and the other 2 loops are either 0 or 1. So far so good. Now we want the if you like, all combinations of paths, and so we're going to have 1 no action, 5, we're going to add 5 items to the basket and 1 deletion. Now, in order to simplify the calculation of all paths, we're not going to have 2, 3, 4 add items. We're going to just go straight to 5, and so fixed insertion will simply say either there are no loops or 5 loops. Accept that. All possible paths. Here we go again. So quite a number here. Okay, we have 20 paths generated by the optimizer. So we're actually going to look for the path that has everything going on. So it's got 1 no action, 5 add items, and 1 delete item, and then the checkout. So let's just see what we find. So that's obviously not it. That's got addition of items but no deletion. That's got 2 items. Oh, sorry. That's got 1, 2, 3, 4, 5 items but no action. That's no good. No action. Add item 1, 2, 3, 4, 5 but no deletion. No action 1, 2, 3, 4, 5 and a deletion. I like that a lot. So let's take number 6. We'll keep going, see what else we get. 7, not very interesting. Nah. Okay, no action. 1, 2, 3, 4, 5. No deletion. No action. Add an item. 2, 3, 4, 5. Another deletion. That's probably a duplicate, but perhaps the sequence is slightly different in the paths that it follows. We'll take it anyway. Number 10. 11, not very interesting. No. No action, 1, 2, 3, 4, 5, no deletion. Action 1, 2, 3, 4, 5. That's another one with 5 additions, and so we'll take that one. No, no. So no action, 1, 2, 3, 4, 5, no deletion. No action, 1, 2, 3, 4, 5, and a deletion. We'll take that. No, no, and that's it. So we've actually got 1, 2, 3, 4 paths that we're interested in. What are these paths? What's special about them? Well, what they are is they provide us with the 4 paths through the no action section of the model. You see these 4 decisions here? So it's where there's a no action, 1, 2, 3, 4. There are 5 add items plus 1 deletion, and that's the combination we're looking for. So this will give us the paths through the no action section. So let's take those that we've selected, store selected, and that's it. So actually now I've got 14 test cases. So these cover the entirety of the model in terms of the elements and paths. We've covered each of the 3 loops at least once, and we've covered all the loops in combination where we have 1 no action, 5 add items and 1 deletion, all of them followed by checkouts. So I'd say this is a pretty good set of test cases that suits me. Okay, let's look back at what we've just done. It makes sense with loops to have a staged approach to creating paths and test cases. We look at each loop in turn and test that loop. We then consider all loops in combination and look at the most complex paths, if you like, through our model. All the time paying attention to coverage of subpaths inside each loop. Now, it can be that with models with no loops, the same incremental approach can also be helpful. For example, you might have a model with multiple endpoints, exit points from the whole process. It might be best to treat the paths to each one of these separately and then incrementally build up your saved test cases. So, in general, you might find it helpful to generate paths according to some criteria and then select the most interesting or valuable ones and add these to your saved collection and iterate until you're comfortable that you've covered the most important and valuable test cases.